Okay, so remember we were talking about this file structure, and we mentioned how the files are stored on this table, either the master file table or the file allocation table. Something I forgot to mention, you have file ID, name, this folder, address. Let's say you have a file 1, 2, 3, the name is resume, DOC, now, and the address. And then you delete the file. Well, there's a parent, right? And there's a folder, system folder. I don't know, what's the ID? It's called recycling bin, right? Recycle bin, or I don't know, recycling bin. It's a folder, and there's no address. So when you delete the file, the parents change to the recycling bin, so you can go there and restore it. But if you empty your recycling bin, do you think it actually erases it from the hard drive? Not at all. Not at all. So remember, we talk about the RAM, that the operating system takes it back at some point when you're done using the RAM, it returns, you just release it, we say. And actually when we did the malloc function, remember I showed you the free function too, to release it? So, it works the same way. What it does is, where this name is, replaces the first character with a question mark. That's all it does. So, flags that address as reusable. The file's still there. That's why you cannot name a file, at least in Windows, starting with a question mark, because that means it's deleted. Eventually, gets overridden by another file that's different. But if it's not, then you can recover it. Narrate. Alright, so we have to talk about files. And there are two types. There's the text files and the binary files. So if you enter the letter A in your keyboard, what does it get transmitted to your computer? The ASCII code of that letter, right? That will be 65. So if you press the number 0, it transmits 48, right? So that's the text. A text file, you can open Notepad, you can read it, right? But if you try to open, let's say, a JPEG file using Notepad, you have no idea what it says there. It's just a bunch of gibberish, right? And the way it happens, so let's say I have, let's pick a number. 1, 2, 3, 4, 5. And what's that number in binary? I'm not gonna try to do it. I mean, we can, but I can just look it up. If you open your calculator and use programmer mode, you can change it to binary. And it says binary, this number is
Can we read it, please?
I got it. 6 zeros and then the first, just 1 1. So, let's look at positions here. 0, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. So if we have a 16-bit, let's say. If it's at 32 bits, the other 16 bits will be just zeros. So that is binary 12,345, right? This is the binary. But what will be the text? So that means each one will be 8 bits. So the text, what will that be? Let's see. Go to ASCIIcode.com. So 5 is 53. What was the other one? No, one of them. Oh, 0, 1, 0, 1. So this is 5. Then 4 goes here. 4 will be 1 less, so it will be and then 3 will be and then 2, man, I'm running out of space here. Fit in the, yeah, I can fit the 1 maybe. So if I were to save this 1, 2, 3, 4, 5 as text, it will save it like this, right? The character or the binary for each character number. If I were to save this as binary, it will save it like this. So it's quite smaller, right? So if this file is binary and I wanted to just open it in Notepad, see what it looks like, what do you think is going to show up? I don't know, let's take a look. So the last 8 is 1001. That will be this one. that'll be number 9. So if I were to open it, it would be 9, and then, what's the other one? Oh, that'll be 0, right? 0, 9. So this binary representation, if I read it as a number, it will be this number. If I read it as text, it will be this number. Or whatever letter should show up. Just happened that was numbers. So that's the problem. You have to figure out if, not a problem, it's your decision, if you're gonna be able to read it. So, an HTML, a website, it's an interpreter, the browser is an interpreter. So if you can right click view source, you can see the code. So that's all text, right? It's not binary. An executable, you don't read the code of the executable, it just runs. So that will be binary. So we're gonna start with text files, and that's all we do today. And then Tuesday we'll do binary files. Okay? So in order to use the we need a library called standard IO. IO means input output, right? So let me erase this. So we're gonna need this library. So we're gonna include it. I need the blue one. So in this, so do you think you have access to the hard drive directly? No, you don't. You have a pointer to the buffer or to the RAM or whatever piece of memory is where you read and write. And then the transaction, when it's committed, save it to the physical hard drive. So this library has a bunch of functions, and also remember we did the structures on types or on data types. It has some data types. They're pointers, and there's this data type called file. And that's a pointer. So, because it's a pointer, we want a pointer, we use the star, of course. We call this my file. So how big is this pointer? 32 bits or 64 bits. That's it, right? Whatever your operating system is. So, remember when we're talking about strings, we use the new line or the tab and the null terminator. But if we want backslash, we'll have to do it twice, right? If we put that in a string. So when we open a file, well, if you're using a PC, the folders are delimited by that backslash. If you are using a Mac, they're forward slashes, so you don't have to do the 2 backslashes. So there's this function called file open. And you have to put a string with the file name. And the file name, if I don't write the full path, this is a string, so you just have to say, my file.txt maybe. It'll assume is where the program is running. Not where your source code is, it's where your program is running. Because the source code, when you compile the program in Visual Studio, you notice there's a folder called bin, which means binary, and there's a debug, and there's a release, and then there's a program. So, unless you put it there, you will need to use the full path. And I have to use 2 backslashes. Well, let's say it's a student. And then documents. And then my file .txt. Now, this function returns a pointer, but you need to tell the operating system, are you gonna read it or are you gonna write it?
Right.
So we're gonna start reading first, the easy part. We have to use a second string and just say, we want read, so lowercase r. And this returns the pointer to that file, so now I can assign it to my file. So have you ever had the problem that if you work in an office and somebody has a spreadsheet open and you want to open it and it says, oh, this spreadsheet's being used by such and such, you can open as read only, because only one person can read and write at the same time. So if you need to modify it and that person actually is not using it, what do? Call them up and said, hey, close that file, I need it. So you need to close a file once you open it, right? Otherwise it's locked. So since there's an F open, you can use a F close. You always close the file when you're done with it. So, how to read from the file? How do you read from the user? Use the scanf function. Right? So the scanf, there's a stream, and it's just basically where are you reading the stream from. You could be reading the stream from the network card. You could be reading from the keyboard. You can be reading from flash drive. You can be reading from your hard drive. It doesn't matter. The computer, once it's looking at a stream source, it doesn't know what source that is. So the scanf is used for reading, is pointing to the keyboard. The underlying code is the same. Just when you start opening, or when you open it, it knows, go to the keyboard. When you want it to go to a file, it's the exact same thing, the scanf. But since this belongs to a file, they put an F in front. And then the functions is the same. Except that you gotta say where you're reading from. So let's say I wanna read a number. Let's see, I have an int current. And I can say, I'm gonna read from my file because the function doesn't know where you're reading from first. And then what type are you gonna read? So, just like the scanf, we say, oh, I wanna read a digit. So you have to know beforehand what type you're supposed to read. And then the address of current. And then I can print F. See what I read. So, what happens if I'm being silly and then instead of using user, I put no, maybe users. Whatever, I made a typo. You won't be able to open that file, right? Because it doesn't exist. So what do you think it's going to return?
No file type or invalid path?
No, this function returns what? Returns a pointer, right? So what do you think what pointer is going to return? If you can't open this function returns, it doesn't print errors or anything, it just returns something.
The address of the file?
But if the path is wrong, it's actually users. So I put user. It's actually users. So that path is invalid. So what is this going to return? What do you think?
Zero. Nothing.
Zero,
No, or return anything.
Well, it returns something. They all return something.
No pointer?
A null pointer.
It's not no pointer.
So before you read, what you gotta do? See if this was null, right? So before you read, I was trying to make room for everything, but I think I miscalculated. So you have to close it if you have a valid pointer. You don't close a null pointer because it doesn't exist, right? So the book doesn't give you much examples of text files. So, how do we know we reached the end of the file? I mean, we can't keep reading through the next file. So in this library, they have some macros, some define. There's a define called end of file. Just call it EOF. So remember when we talk about strings in an array, that the last character was just the null terminator. Same thing with the file. And this text file is a sequential file. So you will be reading, and if it won't fit here. Yeah, all right. Make room here. So, I gotta read something first. I can read numbers or I can read characters, it doesn't matter. So I had scanf, and I have the address of current, right?
It said before my file, before the %D. Yeah, that is-
Oh, yes, I'm sorry. I'm thinking of just the scanf. See, I haven't had coffee yet. I'll do a while loop here. Well, the current is different than the end of file. And let's say print f number and current. And then I'll repeat this function.
What does the word say here? If my file equals what?
Null.
Null?
Yeah. Sorry. It's all caps. So, if I'm not reading numbers, if I'm reading characters, it's not a big deal, right? I can just print. And let's do C. Let's do C. And instead of, let's say it's just a text file, then I'll just put character. So This is a sequential file. That means I start at the beginning and just read down through the whole thing. What do you think? Remember if we want to search something in text, it'll take forever, especially if it's a large file. There's this it's not a function, it's in a database capability. It's called full text search. So you can type something like Google and search. I can tell you how it works. You use the keywords, but if you want to actually search the entire text, it'll take forever. Now, when we open a website, a web page, we simply read from the beginning and load the whole HTML, and then it displays it on the screen. So that's a good case of textual file. Binary is smaller, right? And there are two types of binaries. One is sequential like this. But imagine the file is really, really long. It's like a database. And then you want to do like the binary search we did. So you go in the middle, and then you go to the left quarter, the right quarter, and keep moving back and forth. This only moves in one direction. But if you want to move either direction, that's called a random access file. So those are the ones we're going to talk next week. This week, we're going to talk just text files. And we're going to make a couple files. One, do you know what a batch file is? So you know what a file extension is, right? So if it's exe, it's an executable, right? But if it's a bat, that means it's a batch file. A batch file is a file, and anything in Windows you can do from the command prompt. It's DOS based, everything is DOS based. So what happens is the window makes the command prompt line and then executes the command prompt without you seeing it. They don't reinvent the wheel, right? Like when you make folders and stuff, delete, moves. So this batch file, you can just type whatever you want in the command prompt. And you can save it in a notepad, and then just change the extension to bat, and then it'll execute that. So that's text file. Same thing, the HTML. So to write a file is the same thing, except that instead of reading, what do you think we're going to put here? Right. Right here. And if the pointer is not a null, well, what if it's a new file? Well, the file, if it doesn't exist, it'll create it, right? Otherwise, it'll overwrite it. But if in the path you made a mistake, you won't be able to create it. So it'll return a null. So you still need that part. So if we use the scanf to read, what do we use to display on the screen? So what do you think is going to be for a file? Yeah, just add the printf. And then we have to include the, and the rest is the same.
But is it still D or is it character?
Well, that's not a variable, I just write the number or whatever. So, questions? Did I show you how to make a website?
I've done it though.
Can I erase this? All right, we'll write that code in Visual Studio in a minute. So, somebody said, "Oh, I need a website." Oh, sure, I can make it. I have no idea how to make it. Right. So I got to this website.
Oh, yeah.
Took me 2 hours to learn it there. It's really easy. So the way it works, go by tags. In computer science, we got two type of lists or lists. Yes, one is a queue. A queue is the first one. The first thing that got in is the first thing that goes out, like the printing. Or the stack approach, which is the first one that got in is the last one to go out. And that's how the memory works. And we've been doing the RAM I show you. It's a stack. First thing, last out. So, first thing, last out is the same approach in the HTML architecture. So they use these less than as a tag. And there's a predefined tags. And so if I open a tag, to close a tag, all I do is put the / and then the tag again. Right. Now you have two sections. Yeah, you have the header and you have the body. I mean, you can skip the header if you want, but usually it's not a bad idea to put a header. And you have a body. Now in the header, in the tags, inside the tags will have some properties if you want. And you can add them in here. Let's put a space. Maybe you say background color equal blue. You can have, there's a predefined set of properties for each tag too. So the browser doesn't care if you put them all in one line or you put indentation, or doesn't care. It reads it as a whole. Because we want to read it, we make it this way. If you go to msn.com and right click and view the source, nobody wrote it, it's a computer, so it's a whole one line. So in here we can have title. I mean, you can close the tag in the same line too. And you can say whatever you want. No. Xerox. There you go. Whatever. That's what's gonna show up in the tab of your browser. There are other stuff that goes in here. There's some meta tags. There's a lot of meta tags. And you don't have to close that one. There's a description, keyboard, and other stuff. There's also styles. You ever heard of CSS?
That's pretty stuff.
So this called me for this job interview. Do you know CSS? I'm like, everybody knows CSS. And they're like really animate about it. I'm like, that's the easy part.
Yeah.
That's how to make the letters change colors, font sizes, families, whatever. Make it look pretty. So you can use a style and put all your styles, and then you close the style sheet. Also, you can put scripts like JavaScripts or VB scripts. And that could be in either portion. Usually they're here. And then I think you put language, JavaScript. And there's something else I can remember. Then it's all the code, and then you cross the script. I mean, there's a lot of stuff you can put in there. In the body, is what's on the main screen. In the body, you can write. I make tables. To me, it's easy. You make a table, and it looks really nice, and then you can make tables inside tables. Who cares? So, you can put a table. And you can close the table. Of course, there's other stuff you can put there. You can put border. Let's see if you want border B1 or whatever. So now the table is like a spreadsheet. And if you think of a spreadsheet or a table like a database table, you have the column headers, right? The name of the columns, and then you have the data. So for each one, if you look in Excel, for instance, you might make your spreadsheet, but the first row is going to be your column headers, right? But they have a row. They use a row. So you have to put the headers in one row and then the data in the next row and so on, right? So you need to have a table row. And inside the table row, the first table row is going to have my headers. So I can have table header. And then I can put whatever I want. So maybe I put the pound sign and I close that table header. And then I open another table header. And maybe I put student ID. And I close that table header. And maybe last one is grade. Now that's all I'm gonna put in that row, and then close the row. Then I can put the data inside. It's another row, but this time it's going to have data, so it's table data. This will be one, table data, close, open a new table data, and it'll be 1, 2, 3, 4, 5, close table data, and maybe another one here, and then this guy got an A, close the table data, and then close the row. Maybe this guy, the next guy, doesn't have a grade yet. Because it's the last column, I can just skip it, I don't care. What if I don't have a student ID? The next one. Well, that one I can't skip that well. Because they had to line up. So if I'm gonna leave that one blank, I'm just gonna open and close the tag. And then the last one. Now, I can put images inside there too if I want. So, you get this?
Yeah. I like it too.
So, the HTML means hypertext markup language. Right? Hypertext means you can click on it. A link. Alright, let's move this down so I can fit everything. So close the table, close the body, close the HTML. So that works. So now, let's say if you click the number 4, it takes you to Google. So I open a new row, right? And I open new table data. But if I want to do a hyperlink, I have to use an anchor. They call it an anchor. And then I put the reference, the hyperreference, and I put the full, unless it's in the same website, I put the full path. And then what's clickable there, I put the number 4. And then you close the hyperlink. And then you close table data. And then here. Not all the tags you have to have a closing tag. One of those tags is an image tag. So if you have an image tag, it's just, and like the hypertext, actually this one is called source. And then you can put the full URL of the image. I don't know, images.google.com. I mean this doesn't exist, but I just logo.gif maybe. And I close the image. And then I have to keep it, close the table tag data, and then the table row. Let's say I want to underline the number 1 here. So to underline, I didn't have enough space here. So let's do this. I had it like this. TD, have the 1, close the table tag. So to underline, all I have to do is put a U, and then close the U. There's an I for italic letters, and there's a B for bold letters. There's an S to strike the letters. You can add font, also there's a tag for font, you can change colors in the middle or whatever you want to do. So, easy stuff.
Yeah.
So now you can write text files, you can write web pages from your from a C program. That means you can have your homework. I can give you a new project.
We haven't started the other one.
You haven't started it yet?
Can you
What?
help us?
Yeah.
We're so lost.
It's really hard.
Alright.
Yeah.
Alright, let's take 10 minutes and then we'll work on that.
Can you an extra credit one like that? I love these.